Hello and welcome to week 7 in statistics, where we'll be taking on chapter 7, correlations and regressions. We introduced this chapter with a discussion, as you have probably already heard. Certainly we talked about it in research methods. Correlation is not the same as causation. So read up on that, and then we can go forward on understanding the utility of this very useful test called a correlation. I start off by introducing you to the notion of a scatter plot. Now, a scatter plot is simply, we have two variables, and they're numerical. So we have the values of one on one side and the values of another on another side. So from the book, I'm looking at temperatures in degrees Celsius on this table and ice cream sales. They're so corresponding. There's the day it was 14.2 degrees Celsius, we made $215 of ice cream sales. So what we want to know is in what way are these numbers related? In what way is temperature related to ice cream sales? So we create a chart. We have an x-axis where we put the values of one variable, and we have a y-axis where we put the variables of another. So if we have a variable going along the bottom, a variable going up on the top, and then if we use graph paper and we have a little spot, we have a single point that represents two numbers, the number on the x-axis and the number on the y-axis. We do that for every one of these pairs, and we end up with an image that looks like this. Each one of those dots represents a pair of numbers, one x value and one y value. So temperature along the bottom, sales along the side. Now, each with the arrangement of these spots creates what's called a scatter plot. And this scatter plot visually tells us a little bit about the relationship between these particular variables. You'll see that they sort of make a line here, and the line is lower on the left and higher on the right. It's basically from the bottom left quadrant moving up to the top right quadrant. That shape and those numbers designate what is called it's essentially the slope of that kind of shape that we refer to as the Pearson product moment correlation, or the Pearson R. And that is a number that we use when we calculate the relationship between temperature and sales, or any two variables. In Excel, we put equals correlation. We start writing correlation. Then we put one array, the next array, and we get a number. And that number will be found to be anywhere between -1 and +1. So I give you a graphic of that. So we have this graphic from the course book here. We have a perfect one-to-one Pearson correlation over here on the left-hand side. And then as the spots get a little bit more distributed, we go to a 0.9 correlation, then a 0.5, and then no correlation. And then we start to see the line tilting the other way, where we have values in the upper left quadrant and then a concentration of values in the lower right quadrant. And we have a 0.5, 0.9, negative 0.5, negative 0.9, and -1. Negative, again, we're looking at mathematics here. This is not bad. And negative correlations are simply that as one value goes up, the other one goes down. Positive correlations, they move together. As one moves up, the other one moves up. As they move down, they move down. And the degree to which they do that together is that value. There's no such thing as a Pearson R correlation number that is greater than +1 or even less than -1. It's always a fraction. Now, in terms of the strength of these relationships, perfect correlations, That means those two variables are locked together, whether they're positive or negative, so that one is very strong correlation between those particular variables. In social sciences, however, that's pretty rare. There's other areas of science that use correlations where you see a lot of correlations of very high frequency like that. But in social sciences, a small correlation is anywhere from 0.1 up to about 0.29. And then a medium level correlation is from 0.3 to 0.49, and anything from 0.5 or above in terms of correlation is considered a pretty strong correlation when you're working in the social sciences. It's actually incredibly rare to get higher than that when we're actually collecting data in the real world. Okay, so what does this mean? What it means is when we are trying to understand the human condition, and we're looking at a couple of variables and we're wondering how they relate to each other, ultimately the question we want to ask is, does one cause the other? And we're going to get into that when we talk about experiments. I've already said correlations are not causations. However, if we are going to explore a causal relationship between two variables, we must first establish that they are correlated. If they're not correlated, there is no causal relationship between them. That's just impossible. So the correlation gives us that first indication of there is a numerical relationship between these two variables, and we can then move on to the next step of determining causal factors. Now, correlations also give us something else, and that is if we calculate a line, a straight line, that in our looking at our data best represents that line. That line is referred to as a regression line. It's referred to as a best fit line. And in Excel, it's referred to as a trend line. They all mean the same thing. And that line, if you remember from geometry, has a formula that includes the X and Y variables. So you have y equals something times x plus a number, and that's the y-intercept. If you remember, this is old language. I know for anybody who's doing this, that's a long time ago. That definition of a line gives you an equation. And the cool thing about that equation is that at that point, with some degree of reliability, depending on the strength of that correlation, we can predict one of the variables knowing the other. So if I knew what temperature it was going to be tomorrow, I have a pretty good idea how much ice cream I'm going to sell. Conversely, if I look back in my records, I can look at how much money I made and actually make a pretty good prediction about what the temperature was that day. Won't be perfect, depending on the strength of that particular correlation, but it gives us a good sense of predictability. We now move our statistics discussion from a correlation which is descriptive to a regression which is predictive. And that whole world of regression prediction is a huge component of the world of psychology. In fact, all of the placement tests, SATs, IQ tests, and whatnot are all based, they're all famous because they have some predictive utility. So an IQ test, for example, doesn't really tell us anything. Now that we know, I mean, certainly at this point in your psychological career, you know that IQ is just a piece of intelligence, and people have all kinds of different intelligences. However, it does have predictive utility. IQ predicts how well you're going to do in school. It can be wrong. There's lots of variability. It can be wrong, but ultimately has a pretty good, people who score high on an IQ test tend to do well in school. People who score on another IQ test called the SAT tend to do well in college. People who do well on the graduate record exam tend to do well in graduate school. So we have all of these regressions that have been computed And those tests are sold to admissions departments in order to screen people to make sure they're just accepting people who are going to be likely to succeed. We use regressions in weather. We use them in stocks. We use them in agriculture. We use all sorts of things. We're using regression numbers all over the place. Whenever there's something out there that is trying to predict the future, essentially we have one variable. What's it going to look like down the road? They are using regressions. We have a correlation, and now we're going to use it to create that trend line so that we can predict the other variable. Okay, so when we look at regressions themselves, we are talking about what are called linear models. We have two variables, and we have a linear correlation equation that defines that relationship. We also can use these same tools to do what are called multiple regressions. And these provide us with models of understanding of human behavior and other things where there is a numerical weight given to any given variable and its influence on a given dependent variable. So if you look at, say, success in school, if you look at it from a multivariate point of view, looking at all the different variables, then you'd certainly see that IQ would play a role in predicting. But so does growing up in a family where people have degrees. So a person's socioeconomic status, their capacity to read or to write or to mathematics. If you measure those, each one of those factors weighs in on the ultimate chances of somebody doing well in school. That research has all been done with correlations and regressions, and the multiple regression would assign a weight to each one of those. They don't add up to 100. We'll get into that one later in the class, but it'll say that this particular variable, this particular independent variable, say IQ, contributes to this much of the variance that we see in the dependent variable. Then another variable comes along and says, well, this one contributes this much influence over the variance in that variable. And we capture the complexity of the influences on dependent variables. There's multiple things that can happen, and we do that with a tool called a multiple regression. At the same time, all of this is based on linear relationships. There are instances of what we would call curvilinear relationships, where the relationship between the variables is not a straight line. The example that I use in the course book is anxiety and performance. Here we have research has indicated that too little anxiety leads to low performance, and too much anxiety leads to low performance, and there's an ideal amount of anxiety that leads to peak performance. So we get this curved relationship, which is very different than a linear relationship. And finally, at the end of the course book, I introduce you to the notion of spurious correlations. These are sometimes funny, sometimes curious instances of consistent correlations that exist that do not have any semblance to any sort of causal relationships at all. A very funny one actually involves the state of Maine. The number of divorces in the state of Maine correlates with the sale of margarine in the state of Maine. That's a matter of record. There is no causal relationship between those two, unless And here's the thing: in the discussion, I want you to look up spurious correlations, and I want you to creatively make up what could be the causal relationship there. So if I'm going to look at margarine and divorce, I'm going to say, that margarine causes divorce. We know it doesn't, but because, let's face it, guys, we like real butter. We don't like that. So once our wives start buying margarine, it's just the beginning of the end. If you can't switch to butter, I'm leaving you, kind of thing. So it's all tongue in cheek. But I would like you to consider creatively what could be a causal relationship in these spurious correlations where there are none. Okay, unlike temperature and ice cream sales, you could probably see that there's some sort of causal relationship. As the temperature goes up, we look for ways to cool down our body, and some people like to have ice cream to do that. So the quiz is a multiple choice quiz going over this material. And in the assignment, I'm having you do the 2 tasks of calculating, well, 3 actually. You're taking data, a measure of stress, heart rate, and performance on a test. Doesn't even matter what the test is, but you have heart rate and performance on the test. This is not a curvy linear relationship. I designed this so that it is a linear relationship, although we know that stress and performance is a curvy linear relationship. I want you to create the scatter plot. I want you to use the instructions on creating a trend line, including inserting the equation, and then you're going to also, of course, you'll calculate the correlation, and then I'm going to give you a score on the test that's not within the scores, and I want you to predict what is the most likely heart rate of the individual if they scored there. And so you're actually looking at solving for one of the X and Y. Now make sure that you look at your answer and you don't get the X and Y's mixed up in terms of which one are you solving for when you're looking at doing the equation. So make sure you look at the number and does it make sense as a heart rate, which is the goal. So if you get like 1,050, that person is way dead, and that's not the correct answer. There is a normal heart rate associated with that score. So make sure you look at your answers. You might have got the X and Y variables mixed up when you're solving for the other variable. Okay, so make sure you pay attention to that. This is kind of our first venture into obviously predictive statistics, and then we're going to be getting into some other areas when we're comparing means, and we're starting to get into demonstrating causal relationships between variables and getting into the idea of significance. I've also included, I wanted to add this to the course, and I think it'll be important because some of you are doing correlation studies this semester, and you're going to need to measure the significance, the statistical significance of that, which we haven't discussed yet. We've only discussed it a little bit when we talked about the normal curve. Very rare things happening, and we have those arbitrary lines of 0.05 and 0.01. We use the tool of regression to determine whether or not a correlation is statistically significant or not. And that, when we use the regression tool in the data analysis tool pack, it actually does an ANOVA. We'll get into that later. And when you have 2 variables within that ANOVA, it tells you whether that's significant or not. So I added that video to the timeline. So you can watch that video about how we take the tool pack and we use the tool for regression to find out if our correlation is statistically significant or not. Nice little video. I put it into next edition's course book, so it'll be there next time. So take a gander at that. That'll be important for some of you moving forward in your research studies. So I'll see you online. Have a great week. Take care.